Welcome to Dr. Carminati's channel, your ultimate source for unlocking the raw power and hidden dangers of artificial intelligence. I'm thrilled you joined us today because we're about to blast through the illusions surrounding the tech giants and arm you with knowledge that could safeguard your digital life. Buckle up. This isn't just news. It's a wake-up call that demands your attention right now. Picture this. You fire off a private message to a colleague, spill your deepest business idea into an AI chatbot, or jot down sensitive notes in a productivity app powered by the latest language model. You hit send, the AI responds brilliantly, and you move on, assuming your words vanish into the ether, processed, forgotten, anonymized. But what if I told you that right now, in 2025, cutting-edge research shatters that myth? What if those hidden layers inside the AI hold a perfect, unbreakable blueprint of every single word you typed? And worse, anyone with access to those layers could reconstruct your exact message, word for word, in seconds. This isn't science fiction. It's the explosive finding from a groundbreaking paper that's rocking the AI world. Today, I deliver the whole story, step by step, no jargon overload, so you grasp the stakes, the science, and the urgent steps you must take to protect yourself. Let's dive in and take control of this technology before it takes control of your privacy. First off, let's level the playing field. If you're new to this, don't worry. I start from square one. Language models, those brainy AIs like the ones behind ChatGPT or Grok, work like supercharged translators. You feed them a sequence of words, a prompt, and they churn out responses. Under the hood, they use something called a transformer, the engine that powers nearly every modern AI conversation. Transformers break your input into tokens, think bite-sized word chunks, embed them into numerical vectors, fancy math for turning words into coordinates, and pass them through layers of computation. Each layer tweaks these vectors using attention mechanisms, which let the AI focus on relevant parts of your text, and multi-layer perceptrons, or MLPs, which apply nonlinear transformations to squeeze out patterns. Now, here's where the drama kicks in. Experts long assumed these layers acted like a meat grinder. Inputs get mangled, details blur, and multiple different prompts could collapse into the exact output representation. Why? Because components like ReLU activations clip values harshly, and layer normalization averages them out. This can create potential collision points where distinct inputs map to identical hidden states. These hidden states, the intermediate vectors floating through the model's guts, seemed like abstract summaries, not exact copies. Developers patted themselves on the back, claiming, "Hey, we process your data and discard the originals. No privacy breach here." Regulators nodded along, with bodies like the Hamburg Data Protection Commissioner declaring that trained model weights don't harbor personal info. Safe, right? Wrong. Dead wrong. Enter the revolutionaries, a team of brilliant minds: Giorgos Nicolaou, Tommaso Mencatini, Donato Crisostomi, Andrea Santilli, Yannis Panagakis, and Emanuele Rodola, who dropped a bombshell paper titled "Language Models Are Injective and Hence Invertible." They didn't just poke holes, they dynamited the foundation. These researchers prove, with ironclad math, that decoder-only transformer models, the exact architecture dominating today's AI landscape, map distinct input sequences to distinct hidden states almost surely. In plain English, different prompts produce different fingerprints in the model's brain every single time, with probability 1. No collisions. No loss. Your words etch an unbreakable signature. How do they nail this? They wield real analysis like a weapon. Transformers aren't random black boxes. They're components, embeddings, layer norms, causal attention, MLPs, and residuals qualify as real analytic functions. That means you can expand them into power series, smooth and predictable everywhere except on freakish measure zero sets, thinner than a razor's edge in infinite dimensional space. Collisions? They lurk only on those vanishingly rare parameter configurations. But here's the genius twist. Standard initializations, like Gaussian or uniform distributions, draw parameters from continuous realms that dodge these zero-measure traps with absolute certainty. Training via gradient descent? It preserves this magic. Updates flow analytically. Jacobians stay invertible almost everywhere, and the parameter distribution never slumps into collision hell. Boom. Injectivity locks in from day one and holds through every epoch. You feel that? This flips the script. These guys didn't stop at theory. They unleashed billions of collision tests on heavy hitters like GPT-2, Gemma 3, and Llama 3.1. Pairwise comparisons across massive datasets. Zero overlaps. The tiniest L2 distance between representations clocked in above 10^6 miles from collision territory. Skeptics, eat your hearts out. This isn't cherry-picked. It's exhaustive, empirical annihilation of the lossy myth. But wait, theory and tests are firepower. They needed a practical grenade. Enter SIPIT. Sequential inversion via prefix-wise injective tests. The first algorithm that doesn't just claim invertibility, it delivers it, provably, in linear time. Imagine you're a detective handed a mangled crime scene photo. SIPIT reverses the crime. It exploits the model's causal structure, in which each token's hidden state depends solely on its preceding tokens. Starting from the end, it probes the vocabulary, one token at a time, computing forward passes to match the observed state. Injectivity guarantees uniqueness, no false positives. It enumerates without replacement, verifies with a simple ball check around the target, and reconstructs your prompt token by token. They demo it on real models, nailing exact recoveries every time, even in the presence of noise. This tool doesn't whisper, it roars. Hidden states aren't safe abstractions. They're your data, naked and recoverable. Now, let's hammer home the confidentiality vulnerability, because this is where the real firestorm ignites, and it's why you clicked play. You think deleting your prompt erases the trail? Think again. Hidden states capture the full essence of your input, down to the punctuation. An attacker snags one via a leaky API, a compromised server log, or even a side channel exploit, and SIPIT hands them your secrets on a platter. Business plans? Leaked. Medical histories? Exposed. Trade secrets? Stolen in a flash. This shatters the representations anonymized data lie peddled by big tech. Regulators must wake up. Model internals demand the same safeguards as raw text, encryption, access logs, and deletion protocols. Deployers, listen. Streaming hidden states in real-time chats. Recipe for disaster. One breach, and user confidences flood the dark web. Envision the scenarios that keep me up at night. A corporate exec queries an internal AI for merger strategies. The firm purges the prompt for compliance but archives hidden states for debugging. Hackers infiltrate? Boom! Executives' visions become competitors' blueprints. Or consider healthcare. Patients describe symptoms to diagnostic bots. Clinics store intermediates for model fine-tuning, assuming safety. Wrong. A vulnerability lets adversaries rebuild queries, exposing HIPAA violations and eroding trust. Even open-source models pose risks. Enthusiasts tinker with activations, unwittingly broadcasting community-shared secrets. And governments? They hoard these states for surveillance. Injectivity turns them into perfect eavesdropping tapes. This vulnerability doesn't discriminate. Startups scraping edges with lean APIs. Exposed. Enterprises fortressing data centers. Still vulnerable if they transmit states unsecured. The paper spotlights it starkly. Hidden states are not anonymized abstractions. They are effectively the input text in disguise. Storing or sharing them permanently retains user data. No more hiding behind processed excuses. This demands action, now. Audit your tools. Does your AI vendor log hidden states? Demand transparency. Encrypt transmissions end-to-end. Push for forgetful architectures that truly purge intermediates. And regulators? Enforce labels. Warning, this model retains recoverable inputs. Ignorance isn't bliss, it's bankruptcy. But here's the empowering flip, because knowledge isn't just power, it's your shield. Armed with this, you pivot from victim to vanguard. Demand audits in your contracts. Champion privacy by design in open source contributions. Educate your teams, train them to spot leaky prompts, like avoiding sensitive details in AI queries. Innovators, seize, sip it. Use it for ethical auditing, verifying your models don't leak. This breakthrough doesn't doom us. It liberates us to build unbreakable systems. Imagine AI that heals without harming, connects without compromising. That's the future you forge today. Let's zoom out for the big picture. This paper doesn't exist in a vacuum. It collides with the AI arms race. As models balloon to trillions of parameters, stakes skyrocket. We race toward AGI, but trip over basics like input fidelity. This revelation of injectivity forces a reckoning. Transparency isn't optional, it's existential. It boosts interpretability, enables probing states to understand decisions, and improves safety, letting you trace biases back to prompts. Yet the confidentiality sword cuts both ways. It enables mechanistic interpretability, but amplifies extraction attacks. Balance demands vigilance. For the uninitiated, recap the path. Transformers process text via layers, yielding hidden states. Old view, lossy, colliding. New proof, injective, lossless. Evidence, math plus billions of tests. Tool, SIP, it reconstructs perfectly. Risk, states equals secrets. Solution, encrypt, audit, regulate. You've got the map, now navigate. One final surge. This isn't abstract academia, it's your reality. Every query you make echoes in silicon vaults. Reclaim it. Question everything. Act decisively. Your privacy hangs in the balance. Seize it. What hits you hardest about this? Does it change how you use AI? Drop your thoughts in the comments below. I read every one and reply to fuel the conversation. If this ignited your fire, smash that like button to spread the alert. And subscribe to Dr. Carminati's channel. Hit the bell for daily dives into AI's edge, empowering you to thrive in this tech tsunami. Thanks for watching. Go conquer your day.